Hello everyone, it's Professor Lopez once again. We're continuing with Chapter 1 today, and we will go from 1.3 to 1.6. So, last time we left off, we learned a little bit about environmental biology and some of the problems that we face today. Now, in particular, we're going to be focusing on the human dimension of environmental science and how we, as human beings, play a huge role in not only affecting our environment but also protecting it as well. A great environmentalist by the name of Aldo Leopold once stated that and observed that the great challenges in conservation have less to do with managing resources than with managing people and our demands on resources. So, in this section, we're going to be reviewing some of the ideas that were thought up by various environmentalists over the past century or two and see how their ideas that came about way back then still apply to us today. So, how do we describe resource use and conservation? Well, of course, resource use can be defined as the actual resources that we actually consume. It's here that when we consider resource consumption, an important idea is throughput, or the amount of resources we use and dispose of. When we take into account what we actually use on a daily basis, or the materials that it costs to help, power our homes, either to cool them or to heat them, or the amount of paper that we use in everyday products like toilet paper, the Kleenex, hand wipes, things like that, we start to realize that we consume a lot of raw materials, and that is what is meant by the term throughput. Now, we also have a lot of ecosystem services that are natural and help kind of provision and kind of refill the resources that we have on this earth. And the definition says here the ecosystem services refers to the services or resources provided by environmental systems. For example, we might have certain streams that naturally filter water. That is considered an ecosystem service. Or trees that photosynthesize sunlight energy to create oxygen. That is another form of ecosystem service. Another good example is fungi that break down decomposing or dead matter. Again, that is also considered an ecosystem service. So we thoroughly rely on a variety of ecosystem services to keep this earth functioning as it does. Now, there's also something known as the tragedy of commons that was written by an environmentalist back in the day. And what is the tragedy of commons? Well, it was pretty much a basic question that was given in an essay, and it was by a man by the name of Garrett Hardin. And he was kind of concerned that due to population growth, it would lead to the inevitability of overusing many resources, and therefore we would also have destruction of many common resources that we have in this earth. For example, I'm sure some of you have heard of the term deforestation, which is where we are destroying many forests in many parts of the world simply to provide the resources that we need for paper, for furniture, for wood, and other similar materials. And so that is what Mr. Hardin was referring to when he wrote this essay known as The Tragedy of the Commons. Now, here we have a good example, a good visual example of something I was talking about just briefly, and it is ecosystem services. So we see how photosynthesis, which is a chemical reaction, is a form of provisioning and supporting resources. It gives oxygen, which helps support our environment, and of course also provides food in the form of vegetation that we can consume. And then we see a cow that provides food and fuel. We of course eat the cow if you're not a vegetarian, and therefore it is a form of provisioning. And of course we see a lot of other examples here, and I encourage you to look at this in your textbook and kind of break down each of these individual forms of ecosystem services. Now, when it comes to the form of environmentalism, there are various trains of thoughts, and we're going to get into them a little bit more later on in this chapter when we start talking about the individual environmentalists that were very well known. But one of the things that they were very concerned about was the concept of sustainability, which you have the definition for that here. Excuse me for my stutter. Sustainability is a search for long-term ecological stability and human progress. Okay, so that's what we're looking. We're looking to see if we can sustain a lot of the resources that we have. Can we keep them going for the long term and not just focus on, well, we're only worried about the people that are alive today. We have to think about future generations. And in fact, a man by the name of Gro Harlem kind of created the definition of sustainable development as meeting the needs of the present without compromising the ability of future generations to meet their own needs. And that's something that we, as young people, such as yourself, some of y'all are 18, 19, maybe younger. You have to start thinking about, what kind of world are we going to leave for our children and grandchildren. Obviously we don't like to think that far ahead sometimes, but life does pass us by. And how will it be in 30, 40 years from now? Will we still have a hospitable planet? And a lot of it will fall on your shoulders, because a lot of you will be growing up making the decisions for your future generations. Now, another big thing that seems to be a big factor when it comes to environmental issues is fighting poverty. It says here that policymakers now recognize that eliminating poverty and protecting our common environment are inextricably interlinked. And what ends up happening is that when you have places where you have a lot of poverty, the poorest people are often forced to meet short-term survival needs at the cost of long-term sustainability. So they start performing very dangerous, destructive form of farming methods, fishing methods, because they're only concerned about being able to survive for the day, because they are so poor that they can afford to buy resources. So they have to really just think about themselves at this moment. And so they're kind of foregoing long-term solutions simply to help them survive that day. And that is one of the things that poverty seems to create. And that's why, we need to really pay attention to something like things like poverty that doesn't normally affect places here in America at such a rate as it does in other parts of the world. And we also have to be aware of something called affluence. Affluence is kind of when people have so much money, I guess you could say, and they just aren't aware of the consequences of their actions. It says here that the U.S., with less than 5% of the world's total population, consumes about a quarter or 25% of the most commercially traded commodities such as oil, and produces a quarter to half of most industrial waste such as greenhouse gases, pesticides, and other persistent pollutants. Now, that's a lot. Considering how small a portion we make up in this world, 5%, the fact that we consume a quarter and contribute to at least half of the world's pollution tells me that we are sometimes maybe not realizing how much we're producing in terms of waste and how much we're consuming in terms of resources. So as the rest of the world seeks to achieve a similar standard of living with higher consumption of conveniences and consumer good, what will the effects be on the planet? Of course, everybody across the world would love to be in our shoes, be able to afford a good wage and be able to have the resources that we have. What would happen if the majority of the world consumed the same amount that the United States alone consume? Would we run out of resources quicker, or would we become more aware of our situation? What would happen? That's a pretty good question to ask. And here's a very interesting cartoon that I think kind of helps narrow down what affluence is. And this man is praying at his bed and saying, "And may we continue to be worthy to consume a disproportionate share of the planet's resources." And again, it's, you see this man who has a bed, has lamps, and has a nightstand and paintings, and you might not think that's much, but believe it or not, just that room shows that this man is very well off, even if he only earned approximately $30,000 to $40,000 a year. Compared to other people in other parts of the world, he would be what you would call affluent. He might not be concerned about where his food is coming from, but he will be able to eat, or where his clothing comes from, because he knows he's going to have clothes. And that is what affluence does to us. It kind of helps. It kind of blinds us to where does all the stuff that we consume come from? Where does the material for our clothing, the resources for our food and our furniture, where do they come from? It's not things that we normally think about, and that is because of things like affluence. So, where are we today in terms of poverty? We've talked a little bit about how poverty affects this world and how wealth also affects this world. Well, where are we? It says here that countries with the highest per capita income, they usually take in the people that have more than $40,000 a year, make up only 10% of the world's population. However, those of us, the top 200 wealthiest people, end up consuming about half of the world's resources, or owning half of the world's resources. And that's very, very disproportionate. And we've seen people a couple of years ago, that whole Wall Street March, the 99% versus the 1%. And what that was really all about was the fact that people who are considered the top 1%, despite being in such a small group, make up the decisions, and they can control the resources that affect the other 99%. And so, of course, it doesn't just apply to the United States, but it applies, of course, to other parts of the world as well. And how will that play a role in our environmental issues? Well, again, it means that the more we have to consume as far as income, the more that we'll consume of goods or other resources. So here we see a chart that shows how much more places like North America, Canada, United States make in terms of money per year compared to the European Union and Latin America and South Asia and other parts of the world. And you see that there's quite a difference, quite a gap in income between these different parts of the world. The book also states that some of the biggest safeguards when it comes to protecting this planet seems to be indigenous people. It's here the 500 million indigenous people who remain in traditional homelands still possess valuable ecological wisdom and remain the guardians of little disturbed habitats that are refuge for rare and endangered species and undamaged ecosystems. So here in America, when we think of indigenous people, we tend to think of Native Americans. And we see, for example, that we've been seeing them in the news lately. If you followed the Dakota Access Pipeline news or the No DAPL movement, a lot of it has to do with indigenous people, Native Americans, who are worried that these pipelines that are being installed in the Dakota region will have a negative effect on their sacred lands. And so again, you usually see indigenous people that tend to rise up and protect their land, because usually when they're indigenous means that they were the first peoples that were inhabiting that land. And of course, if you know your history, you know that before Columbus even came to America or discovered America, we already had native people living in this country. And so they of course were very big on protecting their trees, protecting their environment, the animals. They had a very unique relationship to their environment. And so we still see that throughout the world when it comes to indigenous people. Now, switching gears a little bit, almost every biology book that you will read always has a focus on understanding what science is and how the science is going to relate to what we're talking about in this chapter. So number one is, well, what is science? And see, science is a process for producing knowledge based on observations. And so we're going to learn these series of steps, which we call the scientific method. But because of the scientific method, we're able to develop or test theories using certain observation. And of course, here it says science also refers to the cumulative body of knowledge produced by many scientists. Usually when you have a theory or a law, it's not because one individual came up or discovered something, but because many scientists came together and were able to replicate a similar result, thereby producing a theory or a law. Now, it says here that science rests on the assumption that the world is knowable and that we can learn about it by careful observation and logical reasoning. So here we see some of the basic principles of science that are very important when it comes to developing new theories and new laws. Number one, and it's very important, is known as empiricism. To see that we can learn about the world by careful observation of empirical, which is real, observable phenomena or data. We can expect to understand fundamental processes and natural laws by observation. So you realize that just using your basic senses, sight, hearing, smelling, touching, all these different senses that we have are a part of what allows us to observe our natural environment. And that is the beginning to understanding science. Okay. Now, and another big part of science is what we call repeatability, which is the ability to constantly reproduce results, meaning that we did not get any flukes. We're able to develop an average, a mean, and therefore be able to understand if we are performing certain experiments correctly. And I mentioned before, science depends on some type of reproducibility as well as skepticism. It's here that ideally scientists are skeptical, meaning they're hard to come to believe something. They are cautious about accepting proposed explanations until there is substantial evidence to support it. So you'll notice that most scientists are very dependent on things like statistics, verified data, things that can be proven. They try not to rely on their senses, their sight, because sight can be fooled, their hearing can be fooled. So they need to be able to be skeptical in all these things. And of course, just as I mentioned before, reproducibility is huge. The fact that you could reproduce the same result consistently means that you are not coming out with error or flukes. And a part of science is also using what we call inductive and deductive reasoning. Deductive reasoning is, you can think of people like Sherlock Holmes, who are detectives. Well, the word detective usually kind of is a result of deductive, and that is being able to eliminate and come to a logical conclusion. While inductive reasoning is kind of the opposite. It says here, reasoning from many observations to produce a general rule. So you're simply using your senses to develop what we call inductive reasoning. It might not be true, and it might not turn out to be true, but we're only dependent on our senses. Now, one method that we use a lot in science, and some of you may have heard of this already in high school before, is known as the scientific method, which the scientific method is a series of steps that are used to help observe, create an experiment, and kind of come up with results. So the first step of the scientific method is simply make an observation and identify a question. So it gives us a brief example. It says here, your flashlight doesn't light, and you think to yourself, what might be wrong? That in itself, as simple as it sounds, is an observation. Secondly, you propose a hypothesis or an educated statement. The flashlight doesn't work because the batteries are dead. That is an educated statement. Now, are you right? Well, we don't know yet. Are you wrong? We don't know yet. The biggest problem that most scientists or young scientists do or perform is that they will design an experiment with the sole purpose of trying to prove their hypothesis to be correct. Now, any good scientist will tell you that you should never try to prove your hypothesis either incorrect or correct. You simply use it as a guide. So the next step would be to test your hypothesis. And that means to actually design your experiment. And in this case, it's here, if I replace the batteries, then the flashlight should work. And of course, after that, you gather your data, which in this case would simply be after you replace the batteries, did the light turn on? And you would get a simple result. Of course, other experiments can be much, much more complicated. And then after you gather your data, then interpret your results. This is here, if the light works now, then your hypothesis was right. If not, then you should formulate a new hypothesis. Perhaps the bulb is faulty, and then therefore develop a new test. So sometimes you kind of have to go back to the drawing board and see, but where did I go wrong? Maybe did I hypothesize something that shouldn't have been hypothesized? Am I coming at this from the wrong angle? So all this is a part of the scientific method. And so here you see an image, it kind of lays it out for you. And so I would consult this image in terms of knowing and understanding what the scientific method is. Now, as I mentioned before, scientists tend to rely a lot on statistics or statistical analysis. And one of the things that we study in statistics is something known as probability. Since your probability is a measure of how likely something is to occur. Probability does not tell you what will happen, but it tells you what is likely to happen. And so we use a lot of statistics to see how common something really is, or is it a fluke? Does it only have a 5% chance of occurring, or does it have a 95% chance of occurring? Those kind of things do matter. And one great thing about creating a good experimental design is that it can reduce bias. As I mentioned a while ago, one of the key problems that young scientists have is they try to prove their hypothesis correct. What that does from the very beginning is it creates a bias. And we want to try to reduce bias as much as possible. Now, it says here that some of the things that we're going to run into when we do a experimental design is we're going to figure out what is the natural experiment, or one that involves observation of events that have already happened. And of course, we have different forms of experiment. We have manipulative, blind experiments, double-blind experiments. All of these are experiments that have different protocols, but ultimately you use the scientific method in the same way. For example, in a double-blind experiment, this is a very unique one, usually done by pharmaceutical companies and most health-related companies. It says here, in health studies such as tests of new drugs, double-blind experiments are used in which neither the subject nor the researcher knows who is in the treatment group and who is in the control group. In each of these studies, there is one dependent variable and one or perhaps more independent variables. And I encourage you guys to go to your textbook, or you might have to look this up online, but make sure you truly understand what a dependent variable and an independent variable is and how they relate to one another. And of course, as I mentioned before, science is it's a reproductive process, and therefore it's a cumulative process. There needs to be a consensus in science. Everybody needs to be in agreement before something can be put forth as a theory or as a law. Now, what is sound science? We have to be very careful in understanding what is true science and what is fake science. Lately we've been in this political realm that we're in right now. We've been hearing a lot about fake news. How do you know when something is fake and when something is true? The same can actually be applied to science. How do you know when you're dealing with sound science, or are you dealing with what we call junk science? Science that doesn't seem to make sense, has no verifiable data, it seems to be kind of haphazard, and there's no repeatability. So how can you determine what is true and what is not? And so we have this table 1.3 that breaks down some of the questions that you would need to ask in order to determine whether something is sound or not. And I'll give you a good example that is not really environmentally related. However, it's one that I've heard a lot in the past years, and that is whether or not you should or should not vaccinate your children. Of course, those that are opposed are known as anti-vaxxers, and they tend to cite one study that was promoting anti-vaccination. However, you compare one study to hundreds of other studies that prove that you should vaccinate your children, and you see the difference right away between sound science and junk science. And so, I would recommend that you go through these 7 different questions, and I guarantee you that they would help you on other things that are not related to science as well. And critical thinking is another important aspect of science, and that is the ability to think clearly, critically, and analytically about a problem in order to help you, make sure that you get the correct results. And a lot of people right now tend to not think very critically. They simply go with what's in front of them and take it as face value without digging deeper. And so that's one thing that we have to learn as scientists, is to make sure that we think critically, look at every single facet of a problem, and not just go at face value. And so again, here, just like in the previous table, we have another table here that gives us a set of questions that we should ask when it comes time for critical thinking. For example, it's number 1 says, what is the purpose of my thinking? Why am I even giving this any thought? And of course, what conclusion am I aiming toward? What am I taking for granted? These are all questions that you should ask when trying to think critically. And what that does is it helps us analyze information a little bit better. So we see here different forms of thinking that are part of critical thinking. Number 1 is known as analytical thinking, which helps you break a problem down into its constituent parts. In other words, it helps you kind of break down the problem to make it a little bit easier on yourself. Then there's, of course, creative thinking, which is exactly what it sounds like. And it asks, how might I approach this problem in a new and inventive way, something that hasn't been done before. And then, of course, there's logical thinking, which evaluates whether the structure of your argument makes sense. When you think logically, it means that you are trying to get rid of any false information. You're trying to use truth. And of course, reflective thinking asks, what does it all mean? And all of these 4 individual forms of thinking make up a part of critical thinking. And it is through critical thinking that we are able to discover better ways to help and aid our environment. For example, you read in the 1700s, 1800s, places like London, where they were experiencing a big boom in industrialization, were having a lot of issues when it came to pollution. We saw that video early on in chapter 1 that talked about Apple Island and the problem they were having in destroying their reef. It was thanks to people who were able to think critically. They were able to develop solutions to the problem. And that's why you'll see that critical thinking is a necessary component of environmental science. So as I mentioned before, when I first started this video, this chapter discusses various people who have played a huge role in developing the topic of environmental science. And through those people, they develop certain ideas that are still pertinent to this day. And we're going to be looking at some of these ideas that are very essential to us today. Now, these people came up with 4 different views in regards to environmentalism. And it's not to say that one is better than the other. However, we can use all four as to benefit us. And these four stages are resource conservation for optimal use, nature preservation for moral and aesthetic reasons, concern over health and ecological consequences of pollution, and global environmental citizenship. Now, you might be thinking, well, I don't know what this means right now. Well, we'll get into and we'll kind of flesh out these individual ideas. And I want you to focus on that last bullet where it says these stages are not mutually exclusive, meaning you don't have to subscribe to one form of thinking, but you can actually pick all four if you'd like and feel that they're all just as important as one another. So, nature protection has historical roots. Even back in the days of Plato, he contemplated whether or not we were taking care of our environment, if farming methods were being efficient, or there was ways upon improving them. And of course, as I mentioned before, 18th century French and British colonies were looking at different types of pollution that were already occurring, things like soil erosion, which caused crops to no longer grow in that particular area of soil, local climate change due to pollution in the air, and of course deforestation, because that was due to a lot of logging, using wood for many resources. And so what ended up happening was, due to people recognizing these problems, they started coming up with a form of resource conservation. A man by the name of George Perkins Marsh wrote a book in 1864 that was one of the first people to actually think about the idea of environmental protection, particularly in North America. And he was the first one to sound the bells, so to speak, in terms of the consequences that we would have in later years if we kept going at the rate that we were going in regards to destruction of resources. So because of people like George Perkins Marsh, we were able to establish what we now know as the National Parks and Wildlife, where we protect various pieces of land. As I mentioned very early on in Chapter 1, that President Obama has become known as one of the presidents who has protected the most areas of land. Some people are against it, and some people are for it. I kind of fall in the middle because I think we do need to protect these very special places of land, especially places that have historical significance, places that were very important to indigenous people. And so we need to be able to protect these places. Now, that kind of thinking, when it comes to protecting for aesthetic reasons or moral reasons, would fall into the second bullet here, which is nature preservation for moral and aesthetic reasons. However, there are other reasons for protecting various parts of our environment. And President Theodore Roosevelt was one of the first presidents, in fact, who was able to take environmentalism seriously. He was the one who developed the Parks and Wildlife Associations and the notion of preserving pieces of land in North America for protection. And he also had a very good advisor who was also very pertinent to the environmental movement. It's here that Pinchot was the first chief of the Forest Service. He put resource management on a rational and scientific basis for the first time in American history, and helped John Muir and Roosevelt to establish the National Forest, Park, and Wildlife Refuge System. Something that some of y'all may have seen in your time. Maybe you've gone to Yosemite or Yellowstone Park, or other parks here in Texas that have been designated as protected places. This is because of people like Theodore Roosevelt, Pinchot, and John Muir, who were able to establish these organizations. And so here we see some images of some of these conservationists. Now, of course, their form of thinking differed from other conservationists, and they were some arguments. For example, John Muir thought that nature deserved to exist for its own sake, not so much for resource management, but simply because it's so beautiful that we shouldn't touch it. We should leave it as it is. And so that was a different kind of mindset from others, but still, it is a form of environmentalism. And then we have ecologist Aldo Leopold, who formulated and advocated for a land ethic. He was one of those who thought about restoring land. In places of deforestation, we should plant more trees in its place to help restore what was lost. And due to his essays and many writings that he had throughout his life, we were able to establish a lot of the principles of what we now know as modern-day environmentalism. And of course, we now have what we call the modern environmental movement. And a lot of people are looking at the rising pollution levels, whether it be in places like North America, in Asia, places like China, Russia, or even looking at our polar ice caps that are melting at a very high rate. We have now come up with a more modern day movement. And so part of that modern day movement was created by Rachel Carson, who published a book in 1962. And she started looking at pollution that was due to the chemical industries that came about after World War II. And so due to her book, people became more aware of things like toxic chemicals in your everyday products. For example, nowadays you don't ever see paint that has lead in it. But if you talk to your parents or grandparents who were around in the 40s, 50s, having lead in your paint was part of the process. And of course, it was after they discovered the environmental effects, the physiological effects that were being had by painting with lead, that they started to eliminate things like lead in paint, or chlorofluorocarbon, or otherwise known as CFCs, in hairspray cans that were polluting the ozone layer. So it's due to people like Rachel Carson that we were able to understand the different forms of chemical breakdown that we were having in our environment. And so, of course, here we have an image of what Miss Carson looked like. And, of course, we have other examples of other pioneers and activists who played a huge role in promoting the environmentalist movement. For example, we have activist David Brower, who introduced many of the techniques that, in terms of lobbying and activism, we use today. Nowadays we see it even this past weekend with the inauguration. People are prone to activism, which with going out to march with their signs. And it was people like David Brower who came up with good forms of lobbying, which is talking to legislators, congressmen, and letting them understand about the situation of deforestation and other environmental issues. And very common, he was able to approach this from a scientific level and link science along with technology and society and see how we were all having an effect on the environment itself. And so again, we have some images of these two men, David Brower and Barry Commoner. And again, these were considered big men and women in the movement because of just the sheer effect that they had on making people aware of environmental issues. And of course, one concept that's preached throughout the book and we'll see constantly is that environmental quality is tied to social progress. Increasingly, environmental activists are making explicit the links between environmental quality and social progress on a global scale. And now there's a portion in your book that talks a lot about sustainable development that I encourage you guys to read. But it says here that today's environmental movement is pushing sustainable development, or the idea that economic improvement for the world's poorest population is possible without devastating the environment. In other words, how can we help those that are impoverished rise up while having them also think of the long-term implications? In other words, stop thinking simply on short-term, but see what you can do in the long term. One particular advocate that has arisen in this field is known as Dr. Wangari Maathai, and she is a notable example who has supported sustainable development in Kenya, which is where she founded an organization known as the Green Belt Movement. And so we see an image here of Miss Maathai. So what I want you to focus on in this particular chapter is understanding that environmental science that we're going to be going through all this semester is a very important idea, a tool that we need to understand in order to help rectify and solve a lot of the environmental problems that we have. And we're seeing constantly new problems arise, and therefore we're always constantly having to be aware and stay on top of any other problems that may arise. And since you're resolving these multiple problems together is the challenge for sustainability. And we need to really think about the long-term implications of what we're doing to this earth, not just think short-term, but long-term.